Sure. Thanks, Ron. Good morning, everyone. It's always an honor, fun to speak to this audience here in New England, and hope our first 45 minutes lives up to Ron's kind intros. My name is John Mutchek. I'm an application architect developer based in Connecticut. I've been at Microsoft for 12 years, and before that, I spent about 20 years in IT, designing applications, infrastructure across a variety of industries, defense, utilities, financial services. Currently, I work with enterprise customers in the Northeast on application modernization, and really how does the developer culture change and expand into more parts of IT? Things that we traditionally think of being developer processes and tools, really starting to expand into the IT pro space as we drive more and more levels of automation into our cloud-based infrastructure. I've been helping customers work with Azure and get started in Azure for almost 10 years now, pretty much since we first announced Azure back in 2010. And security has always been an important part of that conversation. It's a broad topic, so you're going to get my take on it this morning. Hopefully, some of it will be familiar for those of you that have made the decision to use Azure. But we'll also try to introduce some new insight into what's going on behind the scenes, and also maybe some tools that you can use going forward. We all love tools. Feel free to use the Q&A to jump in, but we're going to start today with that foundation. Why should you trust the Microsoft Cloud? All of the great tech that you're going to hear about today really builds on top of that question, because it really unlocks so much flexibility, so much power. Whether you're work in the server tower deploying virtual and physical infrastructure today, or you are a developer, the flexibility that defining cloud infrastructure brings you just using software definition really can help change your job. It can change the nature of the support that you give to your business, and ultimately we're seeing it changing the businesses themselves. So let's start there. If we're talking about information security, at the end of the day, your jobs are really hard. Cyber attacks are no longer just against governments and large enterprise systems, right? The reality is we're seeing direct attacks against private property, the phones that we carry, the laptops on our desks, even public infrastructure like healthcare providers, schools, and utilities. 20 years ago, we sort of had this feeling that was based somewhat in truth that hackers were teenagers in a basement someplace, and IT pros, usually smarter than the teenagers, usually had better tools, and had the resources that as long as we worked hard enough, we could stay ahead of those hackers and we could keep our data and our applications safe. Today, a very different story, right? Cybercrime is sponsored and executed by very sophisticated international crime organizations and even nation states. And the reality is that there's always more attackers than there are defenders. And they have a huge advantage on their side. They have the advantage of time. They can often work for weeks or months or even years in order to find that chink in the armor. And we as defenders don't always, or really never have that opportunity. They also have the same tools that we do. And in some cases, they might have better tools than you do. And that really starts to be a problem when we talk about the scale of the complexity of this space. Now, recently, ESG did an annual survey, and they found that over 50% of IT pros claim that their organization had a shortage of cybersecurity skills. This is up 23% over just a few years ago. The security landscape's getting more complicated, the stakes are higher, but enterprises just don't have the resources, the budget. Even if they have the budget, they have a hard time finding the skills. And there's a certain reality to the fact that with all of the major technology companies on the planet today, Microsoft being one of them, as your company competes for top cybersecurity talent, you're competing with companies like Google and Facebook and Microsoft and Apple and others that are also looking for that talent. And that really does honestly make it harder to find in local markets. So we live in this target-rich environment. There's billions and billions of devices that are connected, even not counting phones and laptops. And as we connect everything, we create this, this ecosystem, this digital estate that we need to protect. And we really have to ask ourselves the question, well, what is it we're protecting anymore? It's different than it used to be, right? We used to be able to draw a line around the assets that we own, the workstations, the servers, the SAN, the network, and say this is where our applications and data live. Today, you find yourself responsible for protecting technologies that you don't own, personal phones and laptops, devices that partners and customers use to access your systems, which include critical and sensitive data. And so really, you can't draw a perimeter around that organization anymore. It is increasingly blurred to the point where we've actually seen it, it's completely going away in concept. And we do believe that this is a challenge that Microsoft's sort of fundamentally and uniquely positioned to help out with, because we have the ability to look across so many different product spaces, both on the commercial and consumer side, and leverage that insight into what's going on the planet from a cybersecurity perspective, and use that to help you make better decisions about how to secure your data, and also help, even within Microsoft, different product spaces and different services do a better job of protecting applications outside of that traditional perimeter. You don't have to take my word for it here. I'm the only representative from this group that is talking about it this morning, but the reality is that thousands of companies, big and small, have made this decision. And as they've made this decision to use Azure, many of them have actually found that their adoption has accelerated because they found Azure to be more secure than their enterprise data center. And time again, I hear that. And it actually allows us to have this conversation, which sort of flips on its head from where we were 10 years ago. The first conversations that I had with large manufacturing companies 10 years ago about how Azure could benefit their business were always predicated on, convince me that your data center is at least as good as mine when it comes to security. And nowadays, it's actually quite often the opposite, where we are really talking about how do we accelerate the movement of applications and data into Azure, because they see that the investment that we're able to make makes the Azure platform more secure than what they have on-prem. And their customers actually tell them as well. In multiple cases that I've worked on personally, where my clients' feedback has been that our customers telling us that they want us to move this workload into Azure, as opposed to keeping it into a private data center or moving it into one of the other hyperscale clouds out there. So the big question is, how is it possible, right? How is such a massive multi-tenant service more secure than what sits behind that locked door in my own building? I can see that it's locked. I can see who's in there. I can control who has access. And really, we're going to come back to two fundamental points over the course of this morning. It's about scale, and it's about automation to drive that scale. We spend over $1 billion every year on research and development focused just on cybersecurity, and all of that funnels directly towards maintaining that security profile on top of applications and data that you trust us with. What makes Microsoft different from other cloud providers is that we have that intelligence that's informed by trillions and trillions of data sources, individual signal and telemetry that comes in that helps us make smarter decisions about these areas. So we're going to sort of walk through this space in these three pillars: operations, technology, and partnership. So let's start with breaking down operations. What happens behind the scenes? What are the things that we do on your behalf? And then as we get into technology, we're going to talk a little bit more about that shared responsibility and how we provide tools that you can leverage in and outside of Azure as well. So first up, whether you're talking about Azure or Office 365 or one of our other services, we really need to talk about operational excellence. It's how we operate the cloud from the ground up, starting with some of the world's best physical security. That, of course, means fences and barbed wire and biometrics and everything that you would expect to see. For example, a person walking that tries to get access to one of our data centers needs to move through multiple levels of physical security. They need multiple forms of identification. And we're applying additional controls in and out of the data center, such as scanning their pockets for metal on the way in and on the way out to make sure they're not bringing external devices into the data center that could be used to harm the service or to access your data. And we need to apply these standards to meet the strictest industry and government regulations and requirements. And so even if your specific workload doesn't require that level of security, just by simply putting the data in Azure and using the services in Azure, you are getting the benefit of that kind of security that most of us have not been able to implement in a private data center. The other thing we really like to focus on and to talk about is the proactive nature of our testing environment. Right, we are certainly not accepting of waiting to hear about attacks, waiting to see how people are trying to use our services in order to try to improve them and to harden them. And so we're a big believer in red team, blue team exercises. This is where we have a team of professionals, cybersecurity folks that are on the good side. They're on the Microsoft side, but they are pretending to be bad guys, and they are doing so in our controlled environment in Azure and Office 365 and these other services in order to find potential weaknesses. They have a unique advantage compared to some real external threats, is that they actually know a lot about the internal operations of our data centers, and yet they still are challenged to find weaknesses, so that even an insider would have trouble, breaking through these controls. When they do find something, because software is not perfect, and we know that there will always be something that could be better, that problem is immediately assigned as a bug to the engineering team. It's highlighted to the upper levels of management within Microsoft, and it's prioritized as a work item. So we're constantly making sure that those red team items, things that we've found internally, get fixed before they can potentially be exploited externally. And finally, I think it is worth just talking a little bit about restricted access. We talk about the number one question that I get is, yeah, you could say that you protect all of our data and applications from outside threats, but what about inside threats? What about Microsoft? And the reality is that our policies, our procedures, and controls have been very carefully built in order to exclude ourselves from these workloads as much as possible. So Microsoft employees don't have standing access to Azure or Office 365, to your customer data or applications. If in the event that they need elevated access, let's say to do maintenance on infrastructure or to push an update, they need to request elevated access. That gets approved through a chain of command. It is then audited and logged, and they're only given access to the part of the environment that they need for as long as they need it to do that work. And so that elevation of privilege is always logged and audited, and so we have a record of who always did what in the environment. Again, this is something we can invest in from the foundation because it benefits every customer every time they use one of the services. So I want to geek out a little bit here for a minute, because when we talk about cloud security, we do tend to talk about policy. We talk a lot about controls, and many of those controls are human. Some of them, many of them are technical. But if we're going to build the most secure infrastructure on the planet, we need to consider the entire stack from top to bottom. And at the bottom of that stack, as much as we like to talk about platform services and virtualized servers, all of this is still servers. It's still hardware, right? It's compute, network, and storage. And I side of things. And so I think it's worth just sort of talking about how do we look at that. And one of the, I think, most important things that we've done is actually over the last few years, we've been designing our own hardware, server hardware, to run in our data centers. This gives us power over every component, all the way down to the individual chips on every motherboard. And then we can manage the supply manufacturer all the way through to managing and controlling the firmware that runs on those chips individually. Now, this product, or this project, is called Project Olympus. It's actually a part of the Open Compute project. It's in the Open Compute marketplace. which is a industry body that Microsoft is an active member of, where we're trying to open source the good designs that are happening around the industry, around these large-scale data centers, around not just things on security, but also best practices around cooling and other words. So we have designed our own motherboard. We control what chips go onto that. Ultimately, we need to make sure then that the software running on those chips is secure. And so a sub-project within Olympus is something called Project Cerberus that I also find fascinating. Cerberus is a set of standards that define how do we do a secure root of trust on every chip on the motherboard before the operating system boots. So how do we ensure that that hardware coming off of the manufacturing line as it enters into our data center actually is running the software that we think it is? And Cerberus, in addition to a set of standards, is a physical chip, a chip that we designed and are putting on motherboards to, at startup, and then continuously check and attest to the fact that all of the chips on the motherboard are running the firmware that has been authenticated and approved. This goes beyond what you see in UEFI and TPM security that enterprise class hardware has, which typically validates some of the components on boot. This Cerberus project actually validates everything and then continuously evaluates it for runtime changes. And so if malware or something tries to actually change the bytecode, the firmware, while the server is running, Cerberus can detect that and then immediately drop the server out of hosted pools so that we can contain the blast radius and make sure that that infected machine is no longer part of Azure and it can be remediated. But on top of that, it's also validating that every change to the firmware has to be authenticated in the first place, and so we don't expect that variation to begin with. So, again, I think these are just demonstrate the length that we go, or where does some of that $1 billion go, right? Some of it certainly goes to people, it goes to process, it goes to building new software products for security solutions on top of Azure. But it also goes all the way to this base level of making sure that when we are putting a chip into Azure to run a customer workload, that we know that it's running good software from the ground up. Okay, back out of the weeds for a few minutes here. I said this $1 billion partially goes to people, and those people today are about 3,500 dedicated cybersecurity folks at Microsoft that work across a variety of organizations in order to keep our customers safe. The first I'd like to talk about, mention, is the Cyber Defense Operations Center, or the CDOC. This is the organization that defends our services 24/7. It's exactly kind of mission control setup that you would expect when you picture an operations center. They are constantly monitoring signals coming from the service and also proactively looking at the services for anomalous behavior. They have a direct line back to the engineering, and so when something strange does show up, or the evidence of an attack starts to bubble up, we can get the folks that wrote the code that run those services engaged immediately and validate that we are safe against that attack or make changes necessary in order to protect. Another group is the Digital Crimes Unit. This is actually both a technical team and a legal team that helps us fight cyber threats online. Things like malicious software, crimes, intellectual property crimes, and even technology-facilitated child exploitation. To date, last time I checked, they have been responsible for taking down something like 18 criminal botnets and have rescued 500 million devices from secret botnet control. And so this is something partnered with government agencies and other security partners around the world. We're actively looking again at this telemetry that comes in that Microsoft has in conjunction with telemetry from our partners in order to proactively seek out these bad doers, these bad agents, and try to limit their impact on the internet, but also remove them when possible. And sometimes that's just through legal means of takedowns and shutdowns of businesses and fake websites that are key to spreading their malware and botnet controls. Finally, I do think it makes sense to mention quickly something called Microsoft Account Guard. This is another service. It's part of our Defending Democracy program, which is an additional level of cybersecurity protections that are available at no cost to political candidates, parties, non-governmental institutions that are dedicated to election integrity and democracy. And we've also recently expanded that access to that service to healthcare providers that are currently helping fight the global pandemic, to protect them against these attacks that we've seen creep up against hospitals and utilities and others. So you might ask, like, why am I spending so much time sort of walking through some of these different services? I think ultimately it's about the people. It's about these 3,500 plus people. I've never talked to a customer that said, they had plenty of resources, InfoSec, and plenty of budget, and they could do everything that they needed to do. By using these cloud services, it effectively activates a multiplying factor where for your security teams, right? These 3,500 people work for you. That frees up budget and resources in your organization to go and work on threats that are specific to your business, that are specific to your industry, while we can really help you take care of some of that baseline security that everybody needs to worry about. The other thing all these teams have in common is this data, this incoming feed of telemetry and signal that comes from all over the world. We call it the intelligent security graph. It's how we describe all of this data coming in from a variety of sources. 400 billion emails processed every month, 1.2 billion devices scanned by Defender every month. That gives us a ton of signal about what's happening on endpoints. What are the attacks that are going on in the world? Where are they happening? What do they look like this month? We operate over 200 cloud services, and we've been operating cloud services long before there was a thing called Azure or Office 365 or even a term called the cloud. And so we've learned a lot about how to do that at scale. And we also learn a lot from the ongoing operation of those, because we get attacked. We get attacked more than most other companies on any given day. And we learn a lot about the nature of those attacks. And so this is a graph because what's super important about it is the relationship between all of these pieces of data, right? We can layer on top of the data that we collect from our own services, feeds that we get from security partners, from government agencies, from law enforcement agencies, from the proactive botnet scanning that we do, from the digital crimes unit, and then look for patterns across all of this data. Use artificial intelligence and machine learning in order to isolate those patterns, and then find ways to build predictive analytics and protections into the platform itself, sometimes behind the scenes in a way that you don't necessarily see on a daily basis. And as we'll see, sometimes also in the products and services that you can use out of the gate. Okay, so that's operations. Like I said, it's mostly process. It's mostly investment that we make in the ongoing process of keeping these services healthy and building trust in the services themselves. But as we start talking about technology, there's a huge technology stack to talk about. I'm only going to really highlight a few things, but as we talk about them, some of them are things that we do on your behalf. They're sort of behind the scenes. In many cases, you won't ever see them, or really don't even have many controls over them. They are part of the black box of the cloud service. But then you'll also see there are others that are available to you to use on top of your own cloud deployment, or in your on-premises data center that can still leverage some of the benefit of, for example, the security graph. So you've heard this before. Securing the cloud is a shared responsibility. That is never more true than it is today. It always has been. And what we endeavor to do is to give you the tools to make that easy. So, quick stint on some of the built-in controls, the ones that I think are really the most critical for you to be aware of. Certainly identity access management. In this world where the perimeter is no longer your best and last defense, you need the right identity access management controls to decide who can access what, along with full conditional access policies to say who can access what data, under what circumstances, from what device, from what network, and what types of credentials they have to provide, whether that be multi-factor authentication or something more. We need to secure your application and data. Your data really is the most important factor in this equation, and so we'll talk a little bit more about encryption and what we do there. Our threat protection capabilities are built into the platform so that you get a holistic view across both email, collaboration services like Teams and SharePoint, and endpoint devices like your Windows and Mac devices. And then we need to have this sort of ongoing telemetry and visibility at the end by being able to give you the controls, the policy controls, the centralized management of this environment. What is, again, going back to that question, what does that digital state look like all up? Because it's certainly more than the things that just live behind that traditional firewall. So let's start with access. One of the biggest questions that I've always gotten: who has access to your data? And even more interesting, what about Microsoft? Does Microsoft have access to it? And the simple answer is no. We already talked about that those engineers do not have standing access. Nobody at Microsoft has standing access to these environments. In fact, when they request access to work on something, they always have to be working from specialized hardened security workstations that has an additional form of multi-factor authentication on top of them in order to make sure that we don't have bad actors in that environment. Beyond that, both Azure and Office 365 have implemented a thing called the customer lockbox. And the lockbox puts your administrators in that chain of command for approval. So if in that rare event where a Microsoft engineer does need access in order to help troubleshoot a problem, for example, they submit their request for access. It goes up through our chain of command for approvals, but it will also hit your chain of command, and so that somebody on the customer side has to approve access into that environment. And then, of course, that's audited and logged, so you have visibility to when it happens. What about data? This is also, I think, pretty simple. Yes, it's encrypted, right? We encrypt it in transit, we encrypt it at rest. You can optionally bring your own layer of encryption. You can do that with keys that you manage and you control. So ultimately, that blob of data that you've put in Azure is a black box to Microsoft. It keeps even Microsoft administrators out of your data and makes it very easy for us to say, no, we don't have access to it. It's a technical point, but it's also a really critical business point when we think about how Microsoft thinks about the cloud business. We're here to enable you to do more in your business, to grow and to thrive. The data is yours. It's always yours. We make no claim to it, and we're not here to compete with you. And so I think that is both a technical concern and many times a philosophical concern about sort of handing over the keys to your business and to a trusted cloud provider. It's an important consideration and something we take very seriously. For very sensitive operations, we've even invested working with Intel on their secure Enclave SGX technology, so that we talk about data being encrypted at rest, being encrypted at transit, but for those super sensitive workloads, we use confidential computing services in order to keep data encrypted even while it's being processed in memory and by the processor. And so as your code is actually running, that the data that it's operating on cannot even be accessed by the kernel of the operating system, that it is truly a black box. Now, today, this is a really specialized kind of service. Your code, your application has to be written to take advantage of it. But there's tons of advancements that we were working with on Intel in order to make this more and more accessible so that software developers can take advantage of this sort of ideal, sort of holy grail where I can put data into the cloud and even the administrator, super user on the box, kernel routines running on the hardware cannot have access to the data while it's in flight. Cool. of course, I said that your digital estate extends beyond the network perimeter, the network boundary, and that is absolutely true. But we also live in a hybrid world where most of our services that we deploy have been deployed into a secure network perimeter for years and years and years. And so we really expect those same types of controls when we pick up and move many of those legacy applications up into Azure. If we just need to deploy a bunch of servers and we want a fast, flexible, cheap way to do that, then Azure is a great answer, but only if we can also provide you the DDoS protection, the application firewalls, the IP and port-based firewalls that you expect because you use those. And you can either use the built-in capabilities in Azure, but then you can get even more sophisticated network security protections using partner solutions that are available in the Azure marketplace, like Fortinet and others. But I think let's just take one pause here, because networking, I think, is interesting in that you have to understand that behind the scenes in a hyperscale cloud like Azure, all networking is 100% software defined. 100%, we make over tens of thousands of network changes per day. And of course, we could never keep up with that if we had to go in and manually edit router tables and that kind of thing. But it is also representative of a larger security picture here in Azure. And it's super important, I think, to pause and think about this, that I said the two reasons we can make Azure more secure than an enterprise data center are scale and automation against that scale. And we think it's really important for you to think about that that we're doing it, but also to think about it in your implementations as well. So I'm going to use these two slides to illustrate this point. Traditionally, you deploy an application, and I've done it, we've all done it, that's sort of either a off-the-shelf product or a software that you've developed in-house, a line of business application. It gets deployed into a dev environment that some IT professional deployed for you, built the servers to some specification, and then somebody, maybe the developer, maybe somebody else, moves that application to the next environment, to like a test environment, which was also independently built by some external group, maybe the same people, maybe not. And so on and so forth, it moves down the line until it gets to production. One difference is that as it gets closer to production, maybe even in stage, the InfoSec team says, you can't run this unless you meet these security guidelines. And so there's this additional step that comes from this additional group of people to apply security standards, usually towards the end of the process, in order to keep the application safe. Now, our argument is that this has a lot of problems. One is that it just doesn't scale, and I think you all know that how long does it take sometimes to get that last step of approval, to get through information security, to get the application deployed. And the reason it takes a long time is because they're trying to do their job. They're trying to do it properly. And the challenge is that they have a very manual set of tools in order to do it. The way that we fix this problem in Azure, the way that we really are encouraging customers to use on their own environment, and frankly, the way that the most successful large organizations that I've seen deployed in Azure, is that they're moving those security controls further left in the process. Really what we're thinking of is starting to think about is everything as code. Infrastructure as code, even your security standards. It's no longer a security document or a checklist, but it's actually an enforceable set of policy that can be deployed as early as the dev stage of your deployment. And so that as your code moves up from dev to test to staging to production, those security standards are baked in from the beginning. They're approved by the security team from the beginning, so that you don't need additional approvals every time you want to move to the next stage. You also get a whole bunch more baked in testing time because those security standards are applied from the beginning. And it encourages reuse, it encourages consistency, and it really eliminates the drift that you might see from applying one-off security standards to individual servers or server groups along the way. So it's a little bit of a sidebar, but this is crazy powerful when you think about it. And we put GitHub at the middle of this conversation. We tend to think about GitHub as a developer tool. But honestly, more and more, I'm also seeing it as an IT pro tool, because it gives you that central point of engagement where teams can collaborate on what should the security standard be, how should we deploy it, and how do we automate it. Let's see here. So like I said, we have a bunch of tools to help you do that. I'm not going to go into all of these now, but tools like Azure Policy and Blueprints allow you to actually codify what are the security standards that you want to enforce in the Azure environment. I don't want to allow public IP addresses on my websites. They're all internal. I want to enforce encryption standards on all of my storage accounts. I want to make sure there's no public access to storage accounts so that somebody won't leak data via a blob store out on the public internet. These are all policies that you can set at the top level anywhere in your organization, and they'll automatically get patterned down across all of your deployments in Azure. Now I just have a few minutes left, and so let's talk about a few tools. We love tools, we love data, InfoSec teams love data, and so with all of this automation and governance in place, you really want to be able to review your security posture. You want to be able to take actions on them, and you want to get recommendations. The platform, as I've already said, knows a lot about what is going on in Azure, how people are using Azure. And so we can look for anomalies, we can identify best practices, and we can share those with you. So the first and simplest recommendation is turn on Azure Security Center. This is a built-in capability in Azure that continuously assesses your resources deployed in the subscription and makes best practice recommendations. Not just security recommendations, you'll also see recommendations around elsewhere in Azure around cost management, keeping your costs low, high availability recommendations. But here we're specifically talking about recommendations for keeping your resources secure. Those resources might be virtual machines, they might be containers, they might be databases, whatever they are. We want to be able to look at that telemetry and then boil down all of the alerts that are coming in into a set of recommendations. And we even give you this idea of a secure score, which is a numeric analysis of how well you're doing in protecting this environment. And then we categorize high, medium, low security risks, and then give you actions for how you can go and fix those. In some cases, single button click. You should have a web application firewall on this web server, and there's one here in the marketplace. And so if you want to follow this wizard, we will deploy one in front of your web app for you. So Security Center is going to be your first place to go. Now, but we've said with all of this telemetry that represents your digital estate, and Security Center really is focused on virtual and infrastructure. It might not be traditional infrastructure, but it can also actually be used to monitor your on-prem environment or infrastructure running in other clouds. But because it is still just the infrastructure view of the world, we need something bigger. We need something like Azure Sentinel, which is our cloud native SIEM, which imports data from Security Center as well as other sources in order to give you a much broader picture of the security profile of your overall digital estate. And so that does include infrastructure from multiple clouds. It also includes data coming in from partner solutions. And it is, because it's built as a cloud native SIEM, it doesn't have many of the same scale concerns that an on-prem SIEM has. I've spoken to many customers that are constantly looking for ways to reduce their SIEM costs for storage. They're constantly having to add more storage, or their licensing costs for ingestion fees. Sentinel is really about massive scale, bring all of the data, and then use AI and ML to sort out what are the most important correlated events. Now, we also want to make sure that you're bringing in infrastructure and productivity data, and so you can ingest all of your Office 365 telemetry into Sentinel for free. That's a good place to start to get an idea of how this works. But you can ingest any kind of data. And we have some pre-built models in here, ML models that will make recommendations, boiling down millions and millions of signal events into individual events that we can prioritize and help you walk through the triage of those and then the investigation stage. But if you do have your own data scientists, you do want to bring and build your own models, then of course you can do that on top of the platform as well. Once you do have an incident or there's something to investigate, we again use that secure score, we use prioritized guidance, and then visualizations to help you see all of how the attack spread through the environment, what services it impact, maybe where it originated, so that you can reduce that time to resolution as much as possible. And then as you find issues that do creep up, certain types of events you'll find are routine. Maybe you do know that there's a certain type of security event that does happen and it's easily addressable, and you haven't gotten around to fixing the root cause yet. But because we have the entire Azure platform behind us, we can also drive automation off of these events to automatically remediate. So in some cases, it's a security event, a remediation, and a notification out to the security team at the same time, but we're not waking somebody up at night and waiting a few hours to see the remediation. It's actually happening in real time. I know I'm just about up to time. I want to have a couple of questions here. I'd be remiss if I didn't mention, nobody can do this on our own. Microsoft has a lot of data. We have a lot of telemetry. We have a lot of smart people, and we've made huge investments in this space. But the reality is that we wouldn't be successful if we didn't partner across industry, both sharing our data, their data in, sharing our data out with to them as well, in order to build the best possible solutions for you, as well as inviting our partners into the Azure Marketplace ecosystem so that you can pick and choose best of breed services you want to deploy in Azure on top of our security controls, maybe to integrate with things that you already have on-prem, and so that you get the best of both worlds. So that was pretty much what I wanted to talk about today. Hopefully you learned a few things. Maybe there was some review in there for those of you that are already using Azure. But I do think that keep in mind this idea of scale and automation is really the most critical portion of your transition towards a highly automated, scalable, secure cloud environment. Is how can you really automate, push left those security controls as deep into the deployment process as you can, so that there are no more manual steps left.